Hi, I'm Rami Tamimi. Today, I want to introduce you to the concept of topographic surveying and how we can use a survey total station to find the topography of our land and any utilities that might be present on the surface. Topographic surveys heavily depend on elevations and being able to find out how high and low your points are. The last several videos, we've been talking a lot about horizontal accuracy, making sure we know our distance and where we are in terms of space. But when it comes to topos, we're going to be in land that we're surveying. Topographic surveying depends on three things. One, establishing a control network so that we can figure out where we're located in our project. Second, we need to be able to backsite a referenced control point in order to establish a scale for our project. And third, we will then be turning the angle several times and taking several foresights and measuring different points and coding them different descriptions so that we know exactly what we're sighting. Now you could just use your survey total station in a prism and store all the information on the total station. Or you could use a survey data collector. This data collector is going to be attached to our rod right here. And now every time I go to take a measurement, all I have to do is input the information into my data collector, make sure that the total station is able to see me, and then all that information is stored in my data collector. Either method is fine. I mean, you don't have to have a data collector, it just makes things a lot easier. Now in terms of a control network, we only have one setup, so we're only gonna need 2 points. The first control point is this point right here. I'm calling it control 1. The total station will be set up here the entire time. And over here is the second control point that we'll be setting up a backsite to. This will just be a fixed rod with a prism on it. Okay, should be good just like that. I'm just gonna point this in the direction of the total station. Now, if you don't know how to set up a survey total station, I'm gonna recommend that you watch this video. It goes over the basics of how to set it up, how to level it, and make sure that you have good accuracy, because I'm not gonna show you how to do that in this video. Once you've watched that video, come back here and we will go over topographic surveying. Once you've leveled out your total station, let's go ahead and figure out how tall the instrument height is. The way we do that is by using this 25-foot tape. Simply pull and measure the height. Now you want to be measuring where this line of sight is. A lot of total stations will come with a dot that's implemented on the side right here. This is where you want to measure to. Now you want to start measuring by putting the tape all the way at the bottom of your point, and you're going to want to measure all the way up until you see where this point is at. And it looks like it's coming in at 5.05. So our instrument height from the point to our scope is 5.05. The same goes with this rod here. We also need to have the height of this rod. Lucky for us though, all we have to do is look here and see that on the rod it says that this height is 5.2 feet. So we can just input this without having to measure it ourselves. We're going to use both of these HIs and input them into our data collector. But first we need to cite the location of our backsite. To do this, all I'm going to do is use my total station and point it in the direction of the prism. Looks good, and measure. Now this video is making the assumption that you have coordinates on your control points. That's X, Y, and Z. We're now establishing our control network and feeding that information into our data collector so that we can then survey off of it. I've already inputted the northings and eastings of both control point 1 and control point 2. What we're going to do now is tell the instruments where they are in relation to each other. Now I'm going to be using the Carlson data collection software. Now it doesn't matter what kind of software you use. It's all pretty much the same concept, same principles. So just follow along and figure out what kind of information I have to input. All right, so first we're gonna start out by saying that we're occupying point number 1. Our instrument height is 5.05. Our backsite point is point number 2. And the height of the backsite is at 5.20. Okay, and now you can see that our error in the horizontal distance is 0 feet. And the error in the vertical is 0.001, which is very insignificant. It is fine. We can go ahead and set our angle, and this is actually going to be zeroing out our backside. So now our backside is at 0, and we can accept these settings. And this now loads in our project. You can see control point 1 and control point 2. Now I have a robotic total station, which means it's capable of rotating itself and finding the sensor on my prism. Both the sensor on my prism and the sensor on this total station can communicate with each other, allowing this total station to rotate and find me without having someone behind the instrument. Now you don't need to have a robotic total station to perform a topographic survey. However, I am using this new technology, so it will make my life a little bit easier and it will make this process a lot faster. Okay, the first thing I'm going to have it do is rotate and find me so that we can start to collect data. And so the sensors find each other. It now adjusts itself. Great, and the communication is made. All right, let's start our topo survey. Following is the location of points that we want to collect. We're going to be capturing data in this particular location. We're going to be capturing all the features that we can, including concrete sidewalks, curbs, gutters, manholes and catch basins, fire hydrants, signs, trees, and any other significant features along the way. Alright, so to begin, you're going to want to raise this rod to a height that's going to be above you and any obstructions that you see. So for me, I always like to raise this to about 6 feet, and I just kind of get it to 6 feet right here, and then lock it. For anyone that's taller, you may want to go higher. Now you want to change the point number that you're on. I mean, we started at 1, 2 for our control, so it might be good to start at 100. This is a good practice to get your points of control away from your points of topo. Your description will be the type of point that you're picking up, whether it's a concrete sidewalk or a manhole or a light pole. You input this information here. We had control written here for when we were collecting control points. Right here, we're going to put the height of our rod, which is at 6 feet right now. Now we're going to be starting our topographic survey here on this sidewalk. The sidewalk is made of concrete, so I'm going to go ahead and call this concrete. And in the Carlson software system, denoting a number after your code indicates a beginning of a line. Your software might be a little different, so consult with your software manual to figure out what the code needs to be to begin a line. So I'll do concrete 1. Great, and start a new concrete line. So this will be concrete 2. Now after recording the sidewalk shots, I'm going to go ahead and record our curb shot. This is going to just be curb 1. Okay, after taking the curb shot, I will move the instrument down, and this is our gutter. We want to take this right next to the curb shot, but at a different elevation since it's sloping down. So this will be gutter 1. Alright, now I'm at the center line of the road. This will show me exactly where water might be going or just the sloping of the road. So I'll just code this center line road 1. Perfect. On the other side of the street, I have another curb and gutter. So I'm going to create a new gutter line. This will be gutter 2. Okay, take the top of this. This will be my curb shot, and this will be curb 2. Now you'll notice we're going to run into our first major feature, and that is this gigantic light pole. What we're going to do here is just get as close as we can to the light pole, and we're going to take a shot and call it light pole. Light pole. This will be a new sidewalk, so I'm going to call it concrete 3. And it looks like we have the same thing over here, so I'm going to go ahead and start this line. I'm going to go ahead and move over about 50 feet and start to take more shots and begin coding them appropriately. Here is going to be another concrete 4 shot. This is going to be concrete 3. Over here we have curb 2. Down here we have gutter 2. This is the center line of the road, so we'll call this center line 2. This will be our gutter 1. Up here, back a curb 1. And this will be our concrete 2. And this is our concrete 1. Now I want to survey this little area right here. I'm going to show you how we can close out lines so that we can start to use them again. I come down to this point right here, and I can go ahead and call this concrete 1. Same thing over here, I can call this one concrete 2. However, once I come down here, you can see that the concrete actually ends right where this curb is. My coding is going to be curb 1 space concrete 2 minus 7. This could also be E or end or whatever your software is programmed to end lines. Mine just happens to be minus 7. So this will be curb 1 space concrete 2 minus 7. Once you've done a minus 7, you can now reuse this code again. So I'm gonna go ahead and use it right over here to start concrete again. Concrete 2. Also going to be concrete 2, but this is actually where the concrete ends, so we'll go ahead and do minus 7. There are curbs here, so we want to make sure we're including 2 codes, one for the curb and one for the concrete. Curb 1, concrete 2, and there's a gutter, so I'm going to take a gutter shot. Gutter 1. Okay, perfect. You'll notice that we have a sign right here. We need to take a reading on this sign. Sign. Now we ended concrete 1 right there. We're going to take concrete 2 right here. Perfect. And you can see we have a fire hydrant right there, so we're going to take a shot on the fire hydrant. You want to make sure your rod is actually on the ground, and you may want to just tilt it slightly so it's just over the fire hydrant. Great. We'll take our concrete 2 right here, concrete 2. We'll take our concrete 1 over here, our curb shot here, and a gutter shot right here, gutter 1. Perfect. I see that there is a storm catch basin right here. I'm gonna go and call it catch basin. We'll come to the center of the road, I'll move over to the other side of the road. Now we're at a curb and gutter again. Off camera, I'd already finished curb and gutter 1, so I can go ahead and reuse them again. Gutter 1, lower the thing here. Anytime you lower the rod, be sure to put the new rod height into your data collector so it can re-account for the elevation change. Very, very, very important. Curb 1. It looks like we have a tree right here, so we're gonna call for it. It looks like it's about 8 inches in diameter, so I'm gonna call it an 8-inch deciduous tree. The evergreens, or the ones that look like Christmas trees, are called conifer trees. So this is an 8-inch deciduous tree. All right, we're almost done. We're in the final stretch. I see that I have a manhole right here, so I'm gonna go ahead and take a shot on that. Manhole. And it looks like right over here, we have some kind of electricity box. I'm not sure. So I'm gonna hold that here and call it electric box. Really, you can call these codes whatever you want. There's usually some kind of standard at companies that allows the person working on the computer to figure out these codes and generate symbols for them so that they all pop up automatically in their drawing. Once you finish your topographic survey, what you're gonna need to do is re-sight your backsite. Ensure that your backsite is still reading an angle of 0. If it's reading something else, that means your instrument was shifted and altered during your survey. And when I go ahead and look at my prism, take a reading, and we see here that our angle is pretty much at 0 degrees. I mean, it might be a couple of seconds, but that's not a big deal. And there you have it. That is the procedure of collecting data for a topographic survey. And with that, I will see you guys next time.